The outline of this lab was mainly to discuss the vibration of a beam demonstrated with an initial displacement, um, an impact causing an impulse to the beam, and then using adhesives to demonstrate the dampening effects on the said beam. This is the setup. The setup was used taking the same setup as Lab 2 and selecting the high-speed DAC, sampling at 2000 hertz and a buffer of 15,000 samples. This is how the initial displacement was simulated, demonstrating that it was pushed down 2 centimeters or roughly 2 centimeters each time for each test, and what it was at for the reference point before bending. So the first case was the said initial displacement of 2 centimeters. Second one was impulse at a roughly an object dropping from 4 inches in height. And the cases 3 and 4 were using duct tape and double-sided adhesive. The main part of this section of the lab was to correct our data from lab 2 and making sure that the sensitivity is able to correct our values, making sure that they're accurate, as it's seen that my sensitivity came to about 13,741, given the plots of each beam deflection or yeah, beam deflection position and what came of the strain gauge voltages, given the certain load or the force that was applied to it. And then stiffness was calculated the same way as polyfit function was able to give the slope of the data, estimating the stiffness to be 0.0289. So this is the first case showing that after the initial release of the beam, um, it can be seen that the beam vibrates for and reaches equilibrium towards the end, showing its dynamic response. This is the equation for dampening and the natural frequencies. Um, the system should be under damped by a lot because the dampening ratio is significantly less than 1, given the analytical value. And this shows that the analytical value is roughly around the measured experimented data set. These are the spectrum showing that once the first 3 seconds of the beam moving for case 1, the uh, mode seemed to be 3, and it was the same thing for case 2, given the impulse dropping it from about like 4 inches, showing that displacement was 0 because the beam's at rest, and then finally spiking up, hitting a roughly 25 centimeters first. So this is showing the spectrum for case 2. Same thing with 3 modes. And then this shows the tape on the underside of each case, case 3 on the left, and then case 4 on the right. And it's simulated the same way case 1 was done, giving these values, indicating that with tape that the dampening ratio should have increased by a significant portion, demonstrating the add stiffness to the beams. And it shows that the object had the most displacement, but also had the highest dampening ratio. And all of the first natural frequencies were just slightly higher than the damp natural frequencies, indicating that tapes had small dampening effects on the beam.